Hi everyone, in this video I am going to discuss to you the antiderivative of algebraic function, and the focus is going to be on the four fundamental theorems of antidifferentiation. Now before I give you those four theorems and examples, let me just illustrate to you the lesson for today. So here we need to find the derivative of the given polynomial. We learned that in our previous lesson. Here what we will do is we will multiply that exponent 3 to the numerical coefficient of that term or of this term, and then we will subtract 1 from that exponent. We'll do the same procedure here, and then this is going to be 5x raised to 1 minus 1, and we know that that 10 will just be equal to 0. So this is negative 6x squared plus 8x minus 5. So this is the derivative of the given function. But that's not the lesson. We will not be repeating the lesson. What we will be doing is that in today's lesson, this is going to be the given, and then we want, or our objective is to find this. So we call that process anti-differentiation. All right. So let me now introduce to you the four fundamental theorems of anti-differentiation. So the first one is this. The integral of dx, and that equals to x plus c. By the way, this symbol here, before I continue, that's the what we call integral symbol. That's go along with dx, and that dx will tell you the variable that you are going to integrate, because in some cases you're going to have more than one variable. So for the example, so here we need to find the integral of 3, or the antiderivative of 3. Using the theorem, this will just be 3x plus c. There you go. Let's go to theorem number 2. And this theorem is very, very important. This is probably the theorem that you're going to use in most of the problems in doing anti-differentiation. Okay, so please remember this one. So here we want to integrate x raised to n dx, and that equals to x raised to n plus 1. You see that n plus 1, that's the same as the denominator. And of course, don't forget that plus c. For example, we want to integrate x raised to 5 dx. That's x raised to 5 plus 1 over 5 plus 1 plus c, which is equal to x raised to 6 over 6 plus c. There you go. So example number 2, 1 over x raised to 8, and you might be thinking, oh, that's different. No, it's not. Now here you have to use some of your knowledge about loss of exponent. We know that this is equal to x raised to negative 8 using the loss of exponent. So now we can integrate this. So that's x raised to negative 8 plus 1 over negative 8 plus 1 plus c, which is equal to x raised to negative 7 minus 7 plus c. And of course, we want that exponent to be positive, so that would be 1 over negative 7 x raised to 7 plus c. Alrighty. Let's go to theorem number 3. Now here in this theorem, there is an a, or what we call a, that's a number. So it's a coefficient. It's a multiplier, a factor. So what we can do is we can take that out of the integral symbol, and then find the derivative or antiderivative of the function, and that will be basically the procedure. So for example, here we want to take out that 4, and then here I'm going to convert that square root of x into an exponential term. So we know that the exponent of that is 1/2 dx. So this is equal to 4 times x raised to 1/2 plus 1 over 1/2 plus 1, which is equal to 4 times x raised to 3 over 2 over 3 over 2. So don't forget the plus c. And we can still simplify this. This is a complex fraction, so the denominator, which is 3 over 2, we just need to flip that or find the reciprocal of that, which is 2/3. So 2/3 times 4x raised to 3 over 2 is equal to 8x raised to 3 over 2 over 3 plus c. There you go. Let's go to the fourth theorem, and here I'm going to give you 4 examples. Just want to make sure I cover everything. Here's the first one. So what I'm going to do is I will separate that 12x squared plus 2x using the theorem. It says we can do that. So, and theorem number 3 at the same time, we can do both. So that's 12x squared plus dx, by the way, plus 2x dx. So this will be 12 times x raised to 2 plus 1 over 2 plus 1 plus 2 times x squared over, that's 1 plus 1, 1 plus 1, plus c. All right. So we know that 2 plus 1 is 3. This will be 3. But there's a 12 here, so we can divide those two, and that will just be equal to 4x raised to 3. Now in this term, that's 1 plus 1 is 2. We cancel out the 2 here, and that leaves us x squared plus c. There you go. Okay, let's go to the second example of theorem number 4. Now here you might be thinking, oh, I'm gonna just take out that t outside of the integral symbol. Unfortunately, we cannot do that because that t is a variable. So which means here we need to distribute that to negative 3 square root of to 2t and negative 3 square root of t. So this will be equal to 2, using theorem number 3 at the same time, t squared dt minus 3. Now that this is 1/2, so 1, the t has a 1 times plus 1/2, that's t raised to 3 over 2 dt. All right, and this is equal to 2 times 2 t raised to 2 plus 1, 2 plus 1 minus 3 times 3 over 2 plus 1, 3 over 2 plus 1, plus c. There you go. Okay, let's simplify this. This is 2t raised to 3 over 3 minus 3t. 3 over 2 plus 1 is 5 over 2. Right? That's 2 over 2. 2 plus 3 is 5 over 2. Over, obviously, that would just be also 5 over 2 plus c. Now that second term is a complex fraction, so we need to simplify that. So 2t raised to 3 over 3 minus the denominator 2. We should just need to multiply that to the coefficient on top of the numerator 3. That is 6t 5 over 2 all over 5 plus c. There you go. All right, let's go to the third example. There you go. And here, it's not obvious that we can use theorem number 4, but watch this. I'm going to separate that x squared plus 1. So if we do that, this will just be x squared over x squared dx plus 1 over x squared dx. You see that? And then this will just be equal to 1 dx plus x raised to negative 2 dx. All right. So now let's integrate them. 1 dx is just x plus x raised to negative 2 plus 1 plus c. All right. This is now equal to x plus x raised to negative 1 over negative 1 plus c. And the final answer is x minus 1 over x. We all agree that x raised to negative 1 is 1 over x. And then plus c. There you go. And now let's go to the final example, or the last example. Okay, so here, again, you might be thinking, oh, I'll just separate that x squared minus 3 and then the square root of x plus x. Unfortunately, we cannot do that. So here, what we will do is we will expand the two binomials, meaning we will multiply the two binomials using FOIL method. So that means this times that is equal to x. Now that's 2 and this is 1/2. So 2 plus 1/2 is 5 over 2. Then x squared times, oops, x squared times x. There. Plus x cubed dx minus this 3 x raised to 1/2 minus 3 x dx. All right. So next step here is we will now integrate everything. So this will just be 5 over 2 plus 1 over 5 over 2 plus 1 plus x raised to 3 plus 1, 3 plus 1 minus 3 times x raised to 1/2 plus 1, 1/2 plus 1 minus 3 x 1 plus 1, 1 plus 1 plus c. Of course, don't forget that. So this is equal to x raised to 7 over 2 over 7 over 2 plus x raised to 4 over 4 minus 3 x raised to 3 over 2 over 3 over 2 minus 3 x squared over 2 plus c. Now we have two terms here that are complex fractions, so let's simplify them and finalize this. So the denominator 2 goes there on top in the numerator, so that's 2x raised to 7 over 2 over 7 plus x raised to 4 over 4 minus, so that 2 again goes on top, multiply that by 3, but there's a 3 here, so that's 6 divided by 3, which is 2, so we will cancel out the 3 basically. So 2x raised to 3 over 2 minus 3x squared over 2 plus c. There you go. So that's the antiderivative of algebraic function, or the four fundamental theorems of antidifferentiation. So I hope you learned something. Thank you for watching and have a nice day. Bye bye.